Welcome back to another tutorial, and this is two tutorials in a day, and we're going to be reviewing another inverters, and this is a 600 watt pure sine wave inverter. The last tutorial I actually reviewed a 1000 watt modified sine wave inverter, but now I'm going to be reviewing a 600 watt pure sine wave inverter by Ryder. And yeah, without further ado, let's get into it. So for the ones who didn't watch my last tutorials, I actually, as I just said, reviewed a 1000 watt modified sine wave inverter. And a lot of people are probably thinking for the first time, if they've ever watched tutorials like this, is what is a sine wave? So a sine wave is what usually alternating current produces, because since alternating current is constantly in motion, rather than direct current where things flow in one direction, alternating current alternates through in each direction rather than just in one direction. With modified sine waves, they produce what you call square waves. So when you've got an oscilloscope, the waves that produce the AC, the alternating current, looks like a square. You know, when it alternates in squares. With a pure sine wave, it does waves, like actual circular waves with smooth edges, and that's better for your equipment, especially if it's sensitive. So yeah, so without further ado, let's have a look at the device. So nothing on the sides and the top. Well, actually yes, these the USBs on the top and the this is a remote too, an RJ45 remote, that things to it. So we've got two 240 volt outlets, and also two USB 5 volt DC outlets. We've also got a similar setup to, but except this one has two fans on it, and the positive is on the left and the negative's on the right when you're looking at it from behind, which is funny. On the Energy, it's actually the opposite. It's the positive on the right and the negative on the left. This also comes with a remote, so this is what the remote looks like, and this plugs in using what you call a RJ45 jack cable or an Ethernet cable. But the reason why I'm saying RJ45 rather than Ethernet, because this is proprietary. So it's only designed for monitoring purposes. This is not actually a networking, well, it can be used as a networking cable, but technically they don't use it for networking. It's mainly just for a remote. So what we're going to do is we'll plug the remote in. But before we plug the remote in, if I can find it, because this cord is so long, so it gets kind of difficult trying to find. Here it is. So this is what an RJ45 connection looks like. So it looks like a typical LAN cable, typical cat cable, and it is. But in this scenario, proprietarily, it's not used for networking. In this scenario, it's just used for a monitor. So you can monitor everything from the inverter itself. It's got its own screen and buttons to check, but if you've got this down somewhere, like somewhere where it's hard to get at, and you don't want to bend down just to turn it off and turn it on and check the statuses, this is where this remote comes in. So yeah, the downfall about this one compared to the 1000 watt modified sine wave inverter I reviewed before is you can't use the USBs unless the inverter is on. With the other one, you could leave the inverter itself off, plugged into the batteries, and you could still use the USBs. But in this case, you can't. So what we're going to do now is, and another thing I've actually done, I've actually swapped the cables around. So these are the traditional cables that come with it, with alligator, with I-terminal lugs on them, which is alright in certain applications. But what I've done is In my past tutorial I mentioned I had a 1000 watt modified sine wave exactly like the one I reviewed, but I've soldered on, and what I've done is I had the terminal lugs or the alligator lugs to it still, so I swapped out that cabling for this cabling so I can just plug it into a battery wherever I go. So let's get into it. So best practice, you always plug your negative terminal in first, because you don't want to plug your positive terminal in and then ground the negative on something and then next minute you're sparking. So best practice, plug your negative terminal in first. There we go. It's the negative terminal. I'm not too sure if this one sparks, but I'm just going to tap the positive lug anyway, just in case it does spark, because it can be quite thin. Oh yeah, it did produce a little spark. And we'll connect the positive. So the battery is connected. So now we should be able to turn the inverter on. So as you can see, we've got a screen on the inverter, so it says 12.4 on the inverter and also on the remote. So you can see our first option is what you call watts. So that's our, so this has got a voltmeter for the battery. It's also got a watt meter for the how much you're drawing from the inverter, and you've got a percentage of load. So 12.4, so that's like half charged. But let's have a look at the USB cables. So what I'll do is I'll turn the inverter off, and I'll show you if I plug this into the speaker with the inverter off, it doesn't charge at all. Nope. But if I turn the inverter on, and we're charging all of a sudden. What I noticed with the USB ports, it doesn't actually show you how much current you're drawing. The only percentage, the only time it actually shows it is when you've got stuff connected to the AC side of things. So yeah, but it does indicate that it did drop a 0.0 so it must be drawing something from the battery. That's the beauty about this one, is you can actually see the charge, the state of charge and everything like that. So if we unplug the inverter, see now it's flickering 12.4, 12.3. So yeah, but what we're going to do is we're going to try a slow cooker. So I done this on the modified sine wave inverter. What I will tell you is if the load is more than 10% of load, the fans will kick in on this inverter. So anything 10% below, it'll be fine. The inverter won't kick, the battery won't kick in, or the fans at the back. But this will actually bring it up to about 30% load when I turn the slow cooker on. So you'll hear the fans kicking. So let's test. You can actually see how much wattage you're drawing. So in this case it's hard to see, but it says 180, 179. We're at 29% load. I think that's on, yeah, so that's on high. Let's go medium. See, medium drops it a little bit, 129 watts, 21%, and you can hear the audible noise of the fans, because yeah, which is quite cool, because at least I know the heatsink works. I noticed with my the Renogy 2000 watt I reviewed earlier on, a few days ago, that one doesn't kick on the fans, so the fans must be on the thermostat. We see this one, the fans kick in after a certain percentage, and then when you release the load, it'll go back to silence again. So just by doing that test, it's actually stopped. But what I mean is, see, I'll plug this charger in, and if you watch my last tutorial, when I did plug this charger into the modified sine wave inverter, it was making a buzzing noise, but you'll see now, once I plug it into this inverter, it'll make no noise. See? So the inverter is not even the charger that I pinged before is not even making a noise. And it is powered on, I think. Oh no, it's not. Let's make sure that's plugged in properly. Yeah. There we go. See, and it is not buzzing at all, because it is producing a pure sine wave, not a modified sine wave. So yeah, this is the new inverter that I replaced that old 1000 watt modified sine wave inverter for 600 watt. For some reason this one can't start a fridge up, even though it's got the power capabilities of doing it. But I think since it's square wave, it doesn't do too well on compressors. But this one manages to start up a fridge and a freezer, all goods. I've done it in the past. I've tested a few things on it, and yeah, it works like a charm. So without further ado, hopefully you've learnt something new. 2 tutorials in one day. That's a bit of a marathon for me. I just thought I'd get the reviews of these inverters out of the way. So yeah, this is the Ryder 600 watt pure sine wave inverter. I'm not too sure if this maxes out at 1200. I haven't. I noticed once it gets to about 700 watts, it'll just cut off. So yeah. But I'm not too sure if that's because of the wiring I used or what, but I shouldn't see why not. I mean, the wiring is pretty much a similar gauge, but never know. But yeah, until next time, everyone have a good day. I just thought I would review this as well, and until next time, as I always say, cheer cheer.